So she really did just pull that out of a hat. So let's thank her. Next up, we have Christina Grosso of the Aquatic Science Center. She'll be presenting EcoAtlas, which is a tool for visualizing the condition and extent of aquatic resources.
Okay, so as Tony mentioned, I'm going to give you a brief overview today on EcoAtlas, which is an open source tool for visualizing the condition and extent of California's aquatic resources. EcoAtlas is part of a family of tools that was released last year under the guidance of the California Wetland Monitoring Workgroup. So in addition to EcoAtlas, there were several other tools that were released. CARI, which is the California Aquatic Resource Inventory, is a statewide base map of wetlands and streams, and it is used in EcoAtlas as the base map. There's CRAM, which is the California Rapid Assessment Method for assessing wetland condition, and the My Water Quality Wetlands Portal, which provides information on public health, on wetland health to the public. So EcoAtlas aggregates data from several large statewide data sources. There are 3,300 CRAM wetland assessments in EcoAtlas. There's 250,000 miles of streams and about 4 million acres of wetlands classified in CARI, and 150,000 water and sediment toxicity results that are being pulled in for CEDAN. In addition, there are about 800 wetland restoration projects. For the active projects that are currently adding new data such as CEDAN and CRAM, these data sets are updated on a weekly basis. So EcoAtlas aggregates these different data sets and provides synthesis tools for the user to be able to view and download this information. So landscape profiles allow users to summarize these multiple data sources for their area of interest. EcoAtlas is also the main engine that provides the data for the wetlands portal maps, and it also has some project tracking tools. So some of the key features include interactive maps, custom tools for viewing and downloading the data, and a variety of project tracking tools, including a file repository. So the interactive map allows users to customize their view by selecting the content data layers they're interested in exploring in more detail or to help address some of their management questions. There's also overlays such as counties or water board regions that allow users to look at the data through these different lenses. And then there's customized tools for viewing and downloading the data. For example, this is the distribution of CRAM data throughout the state of California, where users can select their area of interest and download the information. So EcoAtlas allows users to customize their views. So for example, this is the Bay Area, and these are the wetland restoration projects that are currently in the system. A user can then add on the wetland condition assessments in CRAM, and then they also add the water toxicity data from CEDAN, which are shown in these color-coded dots that are colored based on the level of toxicity. Once a user has the view that they're interested in, they can use the landscape profile tool to summarize and aggregate this information. Users can select either a predefined area, such as a county or a congressional district, to summarize information, or they can actually draw their own area of interest on the map, and that is shown here in the orange polygon. Once the polygon is drawn, the system dynamically generates a landscape profile that aggregates the information based on the area that they have selected. The wetlands acres, the percentage of wetland acres are provided in pie charts, along with drainage features and streams and miles, both in fluvial and tidal. If there are any historical aquatic resources in that area they have selected, that is also displayed. And a list of the wetland restoration projects and the CRAM assessments, again, for that area of interest are listed. And all of these are active links where a user can select a project they're interested in and drill down to get the actual scores or additional information. Population and housing estimates from the 2010 census are provided, along with a list of threatened and endangered species from the California National Diversity Database. The species are listed along with the quads that have been queried for that information. And the final data set is a bar chart of the percentage of land cover based on the National Land Cover data set. And all this is aggregated to give a user a more comprehensive picture of that area they are interested in. Now, in addition to having a pop-up box that summarizes this information, users can also choose to download a PDF report. And the PDF report provides more information on each of the data sets that has been summarized and some additional analysis of the information. And this is ideal for summarizing progress for a certain area or to document the landscape at a given time, because each report is time-stamped at that date. So how can EcoAtlas support resource managers? Water Board staff in Region 2 are currently using EcoAtlas to evaluate a new project within this larger landscape context. Users can also compare historical and modern aquatic resources in areas that we do have this really rich historical ecology data. And by using the data in EcoAtlas, we can better coordinate restoration and monitoring efforts. We are currently working on improving the landscape profile tool to allow users to upload their own polygon instead of having to draw it each time. And we're also working on saving and sharing the map so that we can have a more collaborative tool. We're working with the Delta Conservancy and the San Francisco and Central Valley joint ventures to develop project data entry tools and editing tools, and also to advance the project reporting that is currently in the tool. And we're always looking for new opportunities to add these additional data layers from systems, from other data systems. So, for example, species abundance or water quality measurements. There's many other data layers that we can bring in that would provide a bit more comprehensive picture of the landscape. Now, I've given you just a really quick tour of an online tool, so I really invite you to go to the website and look at the video that highlights some of the features that I've mentioned briefly here. And here is the URL and my email address if you have any questions. I'd also really like to thank all of our partners and our funders who have been instrumental in making this tool available and developing it. And also a special thanks to Paul Ramsey, who answered our questions to help us optimize some of our spatial queries. So we're very appreciative of that, too. Thank you.
Thank you very much, Christina.